Hey, welcome to Dark Dragon Does Math, and it's 8th grade, part 2, where you're learning the power rule. So I'm going to go ahead and get right into it. If I want to simplify the expression into exponential notation, so I realized the printer wasn't excellent, so this is 2 to the 6th power, and then raised again to the 2nd power. So what this means for us is it's basically, there we go, it's a little better. It's basically saying if we take 2 to the 6th power and multiply it by itself twice, because that's what it's saying. It says 2 to the 6th power squared, so 2 to the 6th power times 2 to the 6th power. And if I write it out like this, it makes a little bit more sense. 6 plus 6 to the 6th power times 2 to the 6th power is 2 to the 12th power, based on the product rule. And that's where we get the power rule. So the power rule is if I have x to the a power raised to the b power, that's the same thing as saying x to the a power times the b power, which we can see here. In the sense that if we could have just done 6 times 2, 6 times 2 is 12. Or if I do x to the 3rd power raised to the 2nd power, that's the same thing as x squared, or excuse, x cubed times x cubed. 3 plus 3 is x to the 6, or 3 times 2 is x to the 6th power. So if we use that thought process, going down the line, 2y cubed raised to the 8th power, and I know this is hard to see, so 2y cubed raised to the 8th power, well, this is just going to be 2y, and then 3 raised to the 3 times 8, which is 2y, 3 times 8 is 24, to the 24th power. And I want to make sure that I keep my parentheses around that one. Mostly being because technically if I take away my parentheses, if I said 2y to the 24th power, this does not equal 2y to the 24th power. Now the reason they're not equal is because this one is just raising y to the 24th power, this one is raising both. So again, that parentheses is very important to recognize that it's raising both here. We could even say, 2 to the 24th power and figure out what that number is, but it's a very, very large number. It's 2 times 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 2 over and over again, 24 times. But if I want to simplify the expression into an exponential notation, again, my base is 1/2. And it's 3 raised to the 5th power, so 3 times 5 is 1/2 to the 15th power. If I get something like this, again, this is 8 to the 8th power times 8 to the 3rd power squared divided by 8 to the 5th power raised to the 4th power. So here I want to go ahead and do the parentheses first. So 8 to the 8th power times 8 cubed. Use the product rule. 8 plus 3 becomes 11. So this is 8 to the 11th power raised to the 2nd power divided by 8 to the 5th power raised to the 4th power. I'm going to use the power rule twice and do 11 times 2. So this is 8. 11 times 2 is 22 divided by 8, 5 times 4 is 20. And then 22 over 20 simplifies to 8 squared. This next one, same idea. Instead of having an 8, we have a b. So we're going to do, this is b times b cubed raised to the 5th power divided by b squared raised to the 4th power. B times b cubed is b to the 4th power, and then raised to the 5th, and then b squared raised to the 4th. 4 times 5 is 20, so b to the 20th power divided by b. 2 times 4 is 8. And then 20 minus 8 is 12, so this is b to the 12th power. Finally, simplify each expression into exponential notation. So I'm going to rewrite this as q to the 5th power times q to the 2nd power raised to the 3rd, and then instead of a division symbol, I'm going to do the bar notation here over q to the 5th. So parentheses first, q to the 5th times q squared gives me q to the 7th power raised to the 3rd power over 5 q to the 5th. This becomes q to the 21st power. 7 times 3 is 21 over 5 q to the 5th. From here, 21 minus 5 gives me q to the 16th power over 5. And I actually don't really like this. This is, you could stop here and this would be right. But instead of saying over 5, I don't know, something about that bothers me. So I actually would write it as 1/5 times q to the 16th power. I feel like that is a little neater, but feel free to disagree there. But anyways, that's the power rule. A few examples of how to use it. I would like you to do as much here, simplify these problems. They should all look relatively familiar, and practice using the power rule. And if we're using the power rule, we're also using math.